Okay, so let's solve some more questions based on ratio and proportion. These are some questions which have been asked frequently in the previous year's papers, these type of questions. They are relatively easy, so let's look at the questions. What number must be added to each of the numbers in order to get the four numbers in proportion? So if I check right now, 4, 6, 8 and 11 are not in proportion. So we need to add the same number, one number, to each of these four numbers so that the new four numbers will be in proportion. So we'll start the solution by saying let the number to be added is, is equal to x. So then we expect that 4 plus x, 6 plus x, 8 plus x and 11 plus x will be in proportion. So when they are in proportion, we will expect that 4 plus x by 6 plus x, that should be equal to 8 plus x by 11 plus x. So if we solve this equation and find the value of x, we will get our answer. Now let us cross multiply. So 4 plus x will be multiplied with 11 plus x, and that is equal to 6 plus x multiplied by 8 plus x. Now let's multiply these two sides carefully. We have 4 into 11, 44, plus 4 into x is 4x, 11 into x is 11x, and x into x is x square. And on the right side, 6 into 8 is 48, 6 into x is 6x, 8 into 8x is 8x, x into x is x square. There is x square on both the sides, so they will be cancelled. And 4x plus 11x is 15x, 6x plus 8x is 14x. Let's move them on the other side. So we will have 44 plus 15x equals to 48 plus 14x. Let's move the 14x to the left and the 44 to the right. So we will get 15x minus 14x, that is x. That is equal to 48 minus 44, that is equal to 4. So the number to be added is 4. You can write that as the final statement, that the number to be added is 4. And if I look at my proportion, if I add 4 to each of these numbers, the numbers will be 8, 10, 12 and 15. So if you verify these four numbers, then will be definitely in proportion. Now let's look at the next question. Question is that the following numbers are in proportion and we have to find k. So it's already given that these four numbers are in proportion. So definitely the meaning is that k plus 3 by k plus 2 is equal to 3k minus 7 by 2k minus 3. Then again, if we just solve this equation and find the value of k, we'll get our answer. So let's again cross multiply. So we are multiplying k plus 3 into 2k minus 3, and that will be equal to k plus 2 multiplied by 3k minus 7. So let's again multiply the two sides carefully. K into 2k is 2k square, and then k into minus 3 is minus 3k. Then 3 into 2k is plus 6k. 3 into minus 3 is minus 9. That is equal to k into 3k is 3k square. K into minus 7 is minus 7k. 2 into 3k is plus 6k. And 2 into minus 7 is minus 14. Now we have 2k square one side, 3k square another side. So k square will not be cancelled, but that's okay. Let's move the 2k square on the right side and everything else on the right side actually, so that one side is 0. We are moving everything from one side to the other. So let's say 2k square on the other side is minus 2k square. So we'll have 3k square minus 2k square, and this results in minus 3x, sorry, minus 3k plus 6k is plus 3k, and that also I'm moving to the other side, so that will be minus 3k, and this side um, already had minus 7k plus 6k, so that is minus k. And again this minus 9 also to the right side is plus 9, and this already had a minus 14. So this entire thing is equal to 0. So I will have k square, this will result in minus 4k, and this results in minus 5. This is equal to 0. So what we have now is a quadratic equation with the variable k. So let's try to use factorization to solve it. You can also use the quadratic formula. The product of numbers we want as minus 5, and the sum of numbers we want as minus 4. So if I try some numbers 5 and 1, I want the sum as negative. So minus 5 and plus 1 will give me the required answer. So I can split the minus 4k as k square minus 5k plus 1k, that is plus k minus 5 equal to 0. Then common factors k into k minus 5, and already here we have a k minus 5, so I can write it as 1 into k minus 5 equal to 0. So that means k minus 5 into k plus 1 is equal to 0. So that means k minus 5 is equal to 0, or k plus 1 is equal to 0. That means k equals to 5 or k equals to minus 1. So this is basically my answer. K can have these two values. But whenever we get two solutions from our quadratic equations, we also need to quickly verify whether both these answers are actually answers to my original question. In my original question, I wanted to find k such that these numbers are in proportion. With positive 5, there should be no problem. If you plug in k equals to 5, you will find they're in proportion. But sometimes we have some issues with negative numbers. It may not be applicable to some contexts. If I put k equals to minus 1, the numbers that we will get is uh, minus 1 plus 3 is 2, minus 1 plus 2 is 1, then 3k minus 7 will be minus 3 minus 7, that is minus 10, and 2k minus 3 will be minus 2 minus 3, that is minus 5. So if I check 2 by 1, is it same as minus 10 by minus 5? So it is, yes, it is same. So we will still say that these numbers are in proportion. So k can also be the negative value, which is minus 1. Only thing is that in case there is a value of k for which any one of these four numbers is equal to 0, then I will reject that value of k, because any number within a ratio proportion cannot be 0. But this is fine. So the final answer is 5 or minus 1.